sources of AC power in a boat?
Generator.
Shore power.
Inverter.
Shore power.
And the shore power, the pedestal. Those are the sources of AC power. Okay, if the boat is on the dock, it's with the shore power and the shore power cable, no? The shore power connection. And where is coming that power?
From the grid.
marina.
FPL,
Yeah.
the CD,
Yeah.
and in this particular CD is coming from Okeechobee Lake, no? And in the Okeechobee Lake, how the electricity is produced on the lake?
Water turbines.
Oh, because the water move a turbine and the turbine move the rotor. Look at this. This is the back end of a generator. This is the back end of the generator. And this is the rotor. This is the rotor. How many poles on the rotor? Four poles. You remember we talked about that? And this is the back end. And we can change. We can turn this one. Exactly. You see? On the stator, my friend, you only have coils. You see the coil? Bam, 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 bam. And those are the poles. You remember what happened when you have a magnet in front of the coil and you move the magnet quickly? Ba, 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 ba.
Produce
What happened? You produce
AC.
electricity. It's exactly the same. This magnet with four poles is moving ba, 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 in front of the coils. You see the coils over there? And produce electricity. How can I move it, this rotor? This rotor is bolted on the engine, on the flywheel. What type of engine I need use to produce electricity?
Diesel.
Gas, diesel, alcohol, propane, any type of motor. Can I connect here a bicycle and yes? But what happened after 10 minutes?
You get tired.
You are tired, no? But can I connect here? This is the plate that is bolted on the flywheel. What happened if in this plate I bolted a turbine like this, and I put a jet of water here?
Spins.
The jet of water, or I put a jet of a vapor, steam, from a boiler. Steam. What happened with the turbine? And the generator?
Power.
Produce power. The thermonuclear plant, I'm going to explain later, is uranium in the bottom and water on top. The uranium increase the temperature, and what happened with the water? Boils and produce vapor, and the vapor spin the turbine and produce electricity. Look at the generator. The generator is divided in the engine. This is engine, gas or diesel, and the back end. The back end is the stator and the rotor. Chapter 14, we are going to talk in details about the generator. This is the back end, the stator and the rotor. You remember the alternator? You have the stator with the coil and the rotor with the magnets in the middle. Papi, AC is produced because the phenomenon of electromagnetism. And this is basically because the iron. Iron is the only element with the property of magnetic properties. Because you have magnets rotating in front of coils, you can produce electricity. Iron is in my opinion, one of the most important elements in the periodic table, because iron we have electricity.
We wouldn't have what we have today.
Because iron we have a lot of gadgets that you have in your hands that change the life of the people. It's because iron is magic. When you move the electron faster, the electrons for the centrifugal force jump it into the coils in front. Look at this. Remember that you have those magnets, strong magnets, no? What happens if this rotor is spinning more than 1,000 RPMs? What happened with the electrons in the surface of this of these magnets.
They jump to
They jump it for centrifugal force, jump it into the coil, and what happened?
produce electricity.
Produce. Oh, if the positive charge pass in front, produce the positive R. If the negative charge pass in front, produce the negative portion.
So those corrode over time because they're losing electrons?
Mm.
Okay.
It's electrons and protons.
Just
Electrons and
Which
protons.
electricity is nothing but a flow of electrons.
Electricity is magic because the electrons, the charge, positive and negative, try to jump it into the coils. Now we are going to talk about the transformers, those elements. And they use the same principle, the principle of induction. Now we are going to talk about transformers. They work with the principle of induction. What is the meaning of induction? Induction is the pass of charge, positive charge or negative charge, because the proximity of one coil pretty close to other coil, one coil powered, pretty close of other coil not powered. The charge pass through the other ones for induction. You understand? This is induction. It's like in a mirror. When you put a mirror, you see other Lopez over there. Oh, nice, good Lopez, in the mirror. But it's basically that the light passed is reflected in the other one. It's similar with the coils. Now we are going to talk about that. Okay, it's clear the production of AC current. It's clear the amplitude. What is the amplitude? Amplitude is basically the same than
The voltage.
voltage. And the output voltage depends on what?
The thickness of the coil.
The thickness of those wires, you see? And the amount of
Rotation.
coils. And the length of those coils. This is the output voltage. This generator is for 5 kilowatts. Suppose that that generator is damaged. Can I remove the rotor and can I remove the stator and send to the machine shop and ask to the guy of the machine shop, hey my friend, I need that you rewind this rotor and this stator to produce not 5 kilowatts, 7. Is possible?
Yeah.
Yes. The guy used thicker wires and more. And they said, okay, come back on Monday. And right now, 7.5 kilowatts. Yeah, because it's more coil, more loops, and thicker loops. That's it. Depend of that. Simple. How can I get a step-up transformer? Pay attention. This is a transformer. Suppose that I have at the input 120 volts with 100 turns. 100 turns. What happens if in the secondary those coils are pretty close, because I need that by induction the electrons jump it in the other one. Look at this. What happens if in the second one I have 200 turns, 200 loops? How much is the voltage here in the secondary?
240.
240. What is the name of that transformer? Step up. What happens if in the secondary I have 50 turns? How much is the output voltage?
60.
60.
Step down.
Nice, no? This is a step up and a step down transformer. Look at this.
Your computers have step.
Yeah, the computers. Look at this. This one is a step down transformer. The input is
120.
120. And in the output they have different options. In between this and this, 60 volts. In between this and this, 40. In between this and this, 80. Because if this one is divided in 3 sections. This is a step down transformer.
Down.
This is the pedestal. This is the typical pedestal in a marina. You see the phases? Phase, and neutral. The neutral is in the middle, phase, and ground is here in the side. Look, phase, neutral, and ground here. Look, phase, neutral, and ground here. All the marinas have those pedestals. Pay attention. In the marina, you remember when you have a dock with 20 pedestals? And you remember that at the beginning of the dock, you have a transformer? Ah, okay. That transformer at the beginning of the dock have 7,000 watts. And in each pedestal, you have
240.
240, 120 amps. 240, 120. 240 plus 240 plus 240 is
7,000.
7,000.
A transformer is like an amplifier.
No, it's a reducer because it's a step down. And this transformer plus the transformer of the other dock plus the transformer of the other dock depend on that one.
Yeah, the big one.
That one divided in those 7 transformers because this marina have 7
No.
slips, 7
7 slip.
docks. You like it? It's clear? Ah, okay, pay attention. In this cabinet at the beginning of the dock, I have, because I have 20 pedestal, I have 20
Breakers.
breakers. Ah, I need check the boat of Jolly and Steve. Is the pedestal 17? Oh, pedestal 17. Off, and I go to check what happened in this pedestal, the pedestal of this boat. Good? This is constant in all the marinas. In the future, you will be the engineers in a marina and you need to respond for the pedestals. Because the customer is calling to the office, hey, I don't know what happened with your pedestal. My air condition pops the breaker every 10 minutes. It's a problem with your power. And you go to the pedestal and you demonstrate to them, no, Mr. Bless, the problem is not in the power of the marina. The power here is perfect. You have a problem in your boat. Can I enter in your boat and I demonstrate that you have a problem in any of your air conditioning equipment? Oh yeah, go ahead. And you demonstrate to them. But you need know, and you need demonstrate in some cases that the problem is here, or in between. Probably is the short power cable the problem. Probably is the outlet, the socket. Yeah, probably the cable is cut and is in short. Or probably is the outlet of the boat. You remember?
Mm-hmm.
Okay. But you need know, because in the future you are the responsible.